Good morning once again. Welcome to today's session. Today we are starting with session 10. It is Introduction to Hypothesis Testing. Right. Introduction to Hypothesis Testing. So here the session goes. After completing this session, you should be able to formulate null and alternate hypotheses for applications involving a single population mean or proportion. Formulate a decision rule for testing a hypothesis. Know how to use the test statistic, critical value, and p-value approaches to test the null hypothesis. Know what type 1 and type 2 errors are. Compute the probability of a type 2 error. So these are your reading list. So what's a hypothesis? Now, we are saying hypothesis is a claim or assumption about a population parameter. So the claims, they get it. Your friend makes a claim, the following claim. So the mean monthly cell phone bill of this city is, so your mean is equal to 42 Ghanaian cedis. So the claim is like what you think is it, do you get it? So the population proportion and so on. So let's move on. We have the null hypothesis. So we represent null hypothesis with H naught, like this, H naught. Then this will come, your mean will come. Plus, and either you have less than or equal to, comma, greater than or equal to, or the equal to sign. Equal to sign. Sorry. So this is less than or equal to, greater than or equal to, then equal to sign. So we are talking about null hypothesis. So the null hypothesis is a statement about a population parameter that will be assumed to be true during conduct of hypothesis testing. So as I said earlier, the null hypothesis is what like the assumption that something is true during a hypothesis or during the hypothesis test. Do you get it? So the assumption to be true during the conduct of the hypothesis test. That's what we call the null hypothesis. So example is the average number of TV sets in a typical Ghanaian home is at least 3. So this one is an assumption, a claim. So you are now going to test whether this claim or assumption is true or false. You get it? So the null hypothesis is either rejected or accepted based on a sample data. Now, we are saying the null hypothesis is talking about the population. So you take a sample and test that hypothesis, whether it's true or whether it's what, false. So example they gave is average number of TV sets in a typical Ghanaian home. Here, the typical Ghanaian home, the population is, they are talking about what? A population. So the average number of what? TV sets in a typical Ghanaian home. So here the average, it means what? Mean, your U. So the average here, the mean here is talking about the population, the mean of a population. So how do we test this hypothesis, whether it's true or false? You pick a sample of it. So you go to central region, you check, you go to eastern, you pick a sample, you get it, and you either accept or reject this null hypothesis that in a typical Ghanaian home, the average number of TV sets are 3. So you sorry. You conduct your this thing, like during the conduct of the hypothesis test, how are you going to accept or reject your null hypothesis? That's what we are going to learn. We are going to learn how to accept or fail to reject. You get it? So how to reject and how to accept. Accepting means you are failing to what? Reject. Do you get it? Okay. So as I said, the mu here is talking about the population. Then you use a sample. That's what they said here. The null hypothesis is either rejected or accepted based on a sample data. The keyword is this one, as they've underlined it. So sample data. You pick a sample and use that sample to test whether the assumption, the null hypothesis, is true or false. Right. So I hope I can move on. So that's what we said here. So NAT is to U. The U mu here is talking about the mean of the population greater than or equal to 3. So this is how you formulate it. You come to it in the subsequent slides. So you do not write HO is equal to S bar. I hope by now we all know what S bar is. Who can tell me like the definition of this symbol here, the S bar? The definition of S bar. So if mu is population mean, what is S bar? S bar is also a mean. So is this population or a sample mean?
Sample mean.
Okay. Thank you. So S bar is sample mean. So the null hypothesis, when you are formulating it, we are much interested in the population, not in the sample. Not in the sample. Do you get it? So we are interested in the population, and the population mean is represented as mu, the U here. Do you get it? And the sample mean is represented as what? S bar. So take note, S bar is sample mean, U is population mean. U mu, this sign here is called mu, MU. It's represented as population mean. And the S bar here is what? Sample mean. Take note, because we'll be using this in this particular session. All right, so let's move on. Now, the null hypothesis HO or HNAT state the assumption or numerical to be tested. So in the previous slide, the numerical assumption to be tested was 3, because they said in a typical Ghanaian home, the average TV set in the home is 3. So the null hypothesis is that assumption or numerical to what? Tested. It states the assumption or numerical to what? Tested. So in the previous slides, or in the previous example, the assumption was that in a typical Ghanaian home, the average TV set is what? 3. So the 3 represents the assumption or the numerical to be what? Tested. So that becomes your null hypothesis. Now the test is always about the population parameter. That's why I said we represent it with HO is to, I think this one is semicolon. HO, H naught is to this sign. Then your mean will come. We are saying is always about what? Population parameter. So the null hypothesis or H naught is always talking about what? Population, not the sample. That's why we represent it with what? The U or MU, not X bar, not a sample statistic. So the sample statistic is what you are going to represent with what? S bar. So we always represent with U, not S bar. Although the test is proven using a sample, we prove the test or the null hypothesis using a sample. But when you are writing or you are formulating it, we just start with what? Mu. HO is to mu. Then the next thing follows. begin with the assumption that the null hypothesis is true. So always we assume that the null hypothesis is what? True. The null hypothesis is always what? True. The null hypothesis is always what? True here. So they are saying similar to the notion of innocent until proven what? Guilty. So it's similar to the notion of innocent until proven guilty. Refers to the status quo. Now, the null hypothesis or HO is refers to as what? Is referred to as status quo. Always contains the equality sign. That is the equal to, less than or equal to, or greater than or equal to sign. And this null hypothesis may be rejected or may not be what? Rejected. So may be rejected or we may fail to reject. That's what they are trying to say. Okay. So these are the characteristics of the null hypothesis. Now let's move on to alternate. Now the alternate is the opposite of what? Null hypothesis. Now it challenges the status quo. Simply, the simple or the simplest form is what? It challenges the null hypothesis. So if the status quo or the null hypothesis is saying the average number of TV sets in a Ghanaian home is less than, is at least 3. At least during the linear programming, we learned that the at least is written as what? Greater than or equal to. So HO is 2. So at least 3. So that formulation will be HO. Then is to U here. At least, so greater than or equal to what? 3, right? Then the alternate hypothesis is represented as what? HA. The null is HO. This one is what? HA. Now this one we are saying it challenges the status quo, or it challenges what? The null hypothesis. So if null hypothesis is greater, is saying that at least 3, then we are saying that it will be less than what? 3, because it is challenging the null hypothesis. Now, the most important thing is that never contains the equality sign, never contains equal to, never contains the less than or equal to, never contains greater than or equal to. So for HA, we have not equal to, because never contains, so not equal to, less than only, not less than or equal to, only less than, or greater than. You get it? So that's what you talk about hypothesis, alternate hypothesis. So your alternate hypothesis is the opposite of the null hypothesis. So it challenges the null hypothesis. And this one too, it may be rejected or we may fail to reject it. So both alternate and null hypothesis, we can reject or we can fail to reject. So failing to reject means you are accepting. You get it? So any question before I
Yes, sir.
Any question before I move on?
No, please.
All right, thank you. So you are saying it's generally the hypothesis that is believed or needs to be supported by the researcher. Okay, now, how do you formulate your hypothesis? So formulating a hypothesis. Now, I said the assumption, the claim will be the null hypothesis. And what the hypothesis that will be challenging it is what we call the alternate. So alternate is the opposite of null. And mind you, the null hypothesis, which is the HO, contains equal sign greater than, less than or equal to, or greater than or what? Equal to. So in an examination or a tutorial set or an example, you see it's exactly this, is this, at least, at most. You see that that statement will be your what? Null hypothesis. But when you hear something like, or when you see something in an application question, less than, greater than, not equal to, they will not write these things for you. You're supposed to know whether this one is not equal to, greater than, or what? Less than. So if your HO is saying the mu, population mu is equal to some particular number, your HA will challenge it. So HA will say that it is not equal to like this. When your HO claims that it is what? Less than or equal to, your HA will challenge it, and that one be only greater than. And if they say your HO is greater than or equal to, your HA will be only what? Less than. Now the packaging department, so let's look at the example here. So we are saying the packaging department. The packaging department of a rice factory would want to know if bags of rice are filled according to the target. According to the target. According to the 5 kg target. So the packaging division of a rice factory will want to know if bags are filled according to what. Now the status quo is mu. It's mu. So the mu will be written, the hypothesis for this one will be written as, now the packaging department is talking about the mu of a population. So HO will be written as mu. They are saying it's always talking about the population. Mu, and they are saying that the target is 5 kg. So it's equal to 5 kg. So it's equal to what? 5. And what will be your HA? We said your HA challenges your what? HO. That's what we are trying to say. The HO challenges your what? HA. Now HA, if HO is saying mu is equal to 5, the HA will challenge it. So it will be not equal to what? 5. If HO is saying it's equal to something, HA is saying what? It's not equal to. If HO is saying that something is greater than or equal to, let's say mu is greater than or equal to, remember the HO always contains the equality sign. So HO less than or equal to the number 10. The HA will be what? Mu. So this is greater than or equal to, so it will challenge it. So it will say that it's less than what? The number 10. So this is how you formulate your hypothesis. You get it? The 5 kg is the status quo. All right. So formulating a hypothesis. So let's look at the second example. Average waiting time at Ecobank Legon branch. So the moment we hear average is what? Mu. Average waiting time at Ecobank branch. Average waiting time at Ecobank Legon branch on Monday to Wednesday is approximately 15 minutes, which management would want to maintain or improve upon. Therefore, occasionally, management randomly pick customers. Randomly pick, so they did a sample. You get it? They perform the sample, like they perform the test using sample, because they are going to test whether the waiting time is approximately 15 minutes or not. So they randomly pick customers and track the time spent between when they enter the bank and when they were served. All right. So here, your HO, you know that the statement is talking about your HO, because approximately, so HO will be dot here, 2 dot here, mu. So what sign are you going to use for approximately?
Equal to.
Approximately. Approximately means like it can be equal to that or lesser than that. So if someone tells you, oh, like it's approximately 100 Ghanaian cedis, approximately 100 Ghanaian cedis, it means that that item or the cost of that item can be 100 Ghanaian cedis or lesser than that 100 Ghanaian cedis. So it can be 100 cedis, 90 cedis, 85 cedis.
Okay.
5 Ghanaian cedis, and so on. But it cannot be more than 5 Ghanaian cedis. Okay, so it will be less than or equal to 15, right? That will be your HO. Oh, sorry, I'm using mouse. Then HA will challenge what? The status quo. So HA will say that HA will talk about the opposite of the HO. So that one too will say that the mu is greater than what? 15. Because they said that the HA never contains the equality sign. So it's less than, greater than, or not equal to. You get it? Not equal to. So this is how you write your hypothesis. This is how you formulate your hypothesis. Any question? Oh,
No, please.
All right. So only if the sample mean waiting time is substantially greater than 15 minutes, then Ecobank managers reject the null hypothesis. They should greater than 15 minutes. Oh, sorry. If only if the sample mean waiting time is substantially greater than 15 minutes, will Ecobank managers reject the null hypothesis and conclude they should probably increase the number of staff to attend the customers. Now, how do you know this? Like, how do you get to know this? How do you conclude? How do you get your conclusion? You are going to learn this in the hypothesis testing. That's why we are learning this session. Because when you formulate your hypothesis, you are going to use certain things to determine your decision rule. If you are to accept the null hypothesis or reject the null hypothesis, and so on and so forth. All right. So let's look at the errors in making decisions. So after formulating your hypothesis and using the test statistic, that's your t-test or z-test, to arrive at your decision. So the decision can be reject your HO or accept your HO. So reject your HO or fail to reject your HO. You can make error in these decisions. You get it? So if instead of rejecting the HO, you accepted the HO. So instead of rejecting the HO, you failed to reject the HO. And instead of failing to reject HO, or instead of accepting HO, you had rejected it. So instead of accepting, you rejected it. Instead of rejecting, you accepted it. These are the two types of error that you can make. Likewise, the alternate hypothesis could be rejected, although true. So as I've explained earlier, in such cases, we say the research has made an error. And we have the errors in making decisions. So we have only two types. For the purpose of this course, we have only two types of errors. So we have what? Type 1 error and type 2 error. Now, type 1 error is when a true null hypothesis is rejected. So you reject a true null hypothesis instead of failing to accept. So the first type of error, type 1 error, is when you reject a true null hypothesis. So let's say the claim from the people, if you reject it, if it is true and you reject it, is the type 1 error. And we are saying that it's considered to be serious type of error. When you reject this type of error, it's really, really serious. So it's considered a serious type of error. So the probability of type 1 error is called what? Alpha. And the alpha is called level of significance of the test set by the researcher in advance. So we'll be using this thing. So bear in mind that alpha here, the alpha here is called level of significance. So the level of significance, we have 5%, 10%, and so on. So you can have 0.05, 0.025, 0.01, 0.1. So these are the values for the alpha. So the type 1 error is when you reject a true null hypothesis, and it's considered to be a serious type of error. And the type 2 error is the opposite of what? Type 1 error. Type 2 error is saying that you fail to reject the null hypothesis. You get it? So instead of accepting the null hypothesis, you rejected that true null hypothesis. So instead of what? Rejecting the false hypothesis, you fail to reject. That's the second type of error. And the probability of type 2 error is called beta. But we normally use the type 1 error. So concentrate here, this aspect. You get it? So we normally use the alpha. You see that consider your level of significance to be 5%, and so on, 0.05, 0. something. So the alpha value or the significance level of significance is what we are going to use. All right. Outcomes and probabilities. So possible hypothesis test outcome. So decision, do not reject. So when HO is true, no error, 1 minus alpha. Reject HO, type 1 error, alpha. So HO is false, do not reject, is what? Type 2 error, that is beta, no error, 1 minus beta. So these things are not really that important. Now let's talk about the level of significance, alpha. The level of significance, alpha, is the probability of making type 1 error when the null hypothesis is true as an equality. Defines rejection level of the sampling distribution. So the level of significance. So I told you the level of significance is the probability of making a type 1 error, the null hypothesis is true as an equality. So defines the rejection region in the sampling distribution. Is designated by alpha, that is level of significance. So the typical values for alpha are 0.01, 0.05, or 0.10. So you have 5%, 1%, and 10%. So these are your typical values or alpha values. Right. Okay, I'm coming. So the level of significance. So in a hypothesis test for say a single population mean. So the single population mean is the sample mean. It's used to test the hypothesis under consideration. However, note that even if H naught, that is the null hypothesis is true, it is possible certain values of sample mean, that is the S bar, will support alternate hypothesis, that is the EG, due to sampling error. In other words, there is room for error. Given the room for error, therefore, what is the probability of rejecting HO? So the probability of rejecting HO is what we term as what the level of significance, which is represented by alpha. In the example below, we are seeing that HO is that, or the null hypothesis claims that the mu is actually less than or equal to 25 days. And you all know that hypothesis, the alternate hypothesis challenges the status quo. That is the challenges what the null hypothesis. So the HA would be mu greater than 25 days. And as you said, the null hypothesis contains the equality sign. So we have equal sign, equal to, less than or equal to, greater than or equal to. And we said that the alternate hypothesis, that the HA, never contains the equality sign. So under alternate hypothesis, we have not equal to, less than, or greater than. So these are the three signs involved. So take note. So if S bar, so this one is S bar. So if S bar happens to fall in the rejection region, one might conclude that HA is true. However, what if this is false? That is, HO is true but is rejected. So we are talking about a type 1 error. When a true null hypothesis is rejected. You get it? So that one, we are saying that that's the level of significance when we reject a true null hypothesis. So the chances of making such error is the significance level, sorry. Right? So let's take an example here. So let's look at the level of significance. We also have three types of this level of significance. So we have the lower tail test, upper tail test, and what? Two tail test. Now, I'm going to share the screen. So as I said, for the lower tail test, the HO, for the HO, the mu is less than or equal to a certain number. Let's use 3. And the HA, let me use this one, okay. Let me use the capital S. Will be, if this one is greater than or equal to 3, this one will challenge it, so it will be less than 3. So this is the lower tail test. All right, so this one is the lower tail test. So every lower tail test, your H naught, the mu must be greater than or equal to a certain number. That one becomes your upper tail test. So this one, see something like this. Your rejection level will be here. So rejection level, sorry. Your rejection level will be here. You get it? Sorry, okay, I'm using the months is not working like that. So rejection level will be in the shaded region here. You get it? So this is what we call the lower tail test. Now let's move on to the upper tail test. So for upper tail test, your mu2 must be what? For the H naught or the null hypothesis, the mu must be less than or equal to a certain number, say 3. And your HA, the mu will challenge the status quo or will challenge the null hypothesis. So if this one is less than or equal to 3, this one will be greater than or equal greater than 3. You get it? So when you see something after formulating your hypothesis and you see something like this, bear in mind that your test is what? Lower tail test. So that one too, you see something like this. Okay, so when you see something like this, it's talking about what apartheid test. So the apartheid test, your null hypothesis, the mu is less than or equal to a certain number, and your alternative hypothesis, the mu is greater than a certain number. So when you see something like this, it's talking about what apartheid test. So this one, your rejection level. Sorry for the curve. So the rejection level will be here to the right. You get it. So that will help you solve for the probability. Now, so now we have lower tail test, upper tail test. Now, when you are looking for the probability of this shaded region, you all know that the table, if only you are using the Z table, it reads to the left. So you have to solve for the bigger side, that's reading to the left, and subtract whatever you get from 1. That will give you the probability of this shaded region. That's the upper tail test. All right, take note. So I will illustrate this when we are solving a question. Now let's move on to the third one. That one is two-tail test. Two-tail test. So with this one too, your HO or your H naught, the mu will be equal to certain number, and as we know, the HOA always challenges what? The status quo. Or will be not equal to what? 3. All right. So as the name implies, two-tail test. So it means the rejection level, you are going to get what? 2 rejection levels. We are going to get this side. We are going to get what? This side. Right. So I hope everything is clear, right? So this one returned as two-tail test. So with the lower tail test, after formulating your hypothesis, and as at now, I think all of us know how to formulate a hypothesis. After formulating a hypothesis, it will help you determine whether you are getting lower tail test, you are getting upper tail test, or you are getting what? The two-tail test. So whenever your mu for H naught, the mu is greater than or equal to 3, then bear in mind that you are talking about that lower tail test. Whenever you're not, that's the HO, the null hypothesis, the mu is less than or equal to a certain number, then bear in mind we are talking about the upper tail test. And whenever your HO, that's the null hypothesis, the null hypothesis is actually equal to a certain number, then we are talking about two-tail test. I hope we are clear. Can I move on?
Yes, please.
Let me go back to the slides. So as I said, this is our shaded region. You get it? And you call this one level of significance. So that's what you represent by the alpha value. Then your critical value will be here. This star. So they've represented that one. So critical value, this star represents the critical value. Then the shaded region is the what? Rejection region. And now the two-tail test, when you have something like this, you're going to divide your alpha by 2. So the alpha, if it's 0.05, you divide it by 2 to get what? 0.025. Okay, so you divide your distance by 2. So take note for two-tail test, right? So let's move on. Okay, so we have 2 approaches. We have critical. We said we have 2 approaches in testing this statistics. So we say we have critical value approach, and we also have p-value approach. So let's tackle the critical value approach. It said convert sample statistic to test statistic. So it's either Z or T, and we come to these ones. So we have the Z formula and we have the T formula. Determine the critical values for a specified level of significance. So the critical values, you get it. So that one depends on the alpha. So if the alpha is 0.05, you go to your distribution table, that's your Z table, then you come through to search for 0.05, then you trace it to get your what? Critical values. So you trace it to the top and to the left, and you get what? Your critical value. If the test falls in the rejection region, reject the HO, otherwise do not reject it. So we have the decision rules in this, like either to reject HO, reject null hypothesis, or what? We fail to reject the null hypothesis. Alright, so this one is talking about the one-tailed test. One-tailed test. And I told you that one-tailed test, always your null hypothesis, the mean is greater than or equal to certain number. And the HA will challenge it. That the mean is less than 3. You get it? So we are seeing that the cutoff value, it is Z alpha, is called a critical value. So the decision is that reject HO or reject null hypothesis if our Z computed. So we are going to calculate the Z figure here. It's actually less than or equal to what? Z critical, because the negative Z, they are saying is what? The critical value here. So if your Z computed is less than or equal to Z critical, we are saying that reject H naught, reject null hypothesis. And after solving for your Z computed, if it's greater than critical value, is opposite to this, you fail to reject. Okay, so let me give you the rule. Let me type it here. So they are saying that for lower tail test, they are saying that reject HO if Z computed is less than or equal to Z critical value. Then we reject what? We reject HO. You get it? And if Z computed is greater than what? Z critical value, we fail to reject. We reject what? The H naught, as they fail to reject the null hypothesis. So this rule is very, very important. So this one is for the critical value approach. Now I also have something like p-value approach, but I'll not teach that one because you might get confused with the two. So let's maintain the critical value approach. So that one you compare the Z computed and the Z critical. But with the p-value approach, as the name implies, P, you are going to compare their probabilities. So like you find the probability of the Z computed and the probability of the critical value. And you already know the probability of the critical value, that will be given to us in the question. That is the level of significance. So if your level of significance is 5%, that is 0.05. You also go and search for the value or the probability of what is Z computed. So let's say after solving the question, your Z computed was what? 1.75. You go to the table, you look for probability for 1.75. Then you compare with the critical value, which is 0.05. And the decision rule is different from this one. It's opposite to this one, but I don't want to go to the other side. So just stick to this rule. So for lower tail test, if Z computed is actually less than or equal to Z critical, we reject the HO, reject null hypothesis. And if Z computed is greater than Z critical, we fail to reject what? HO. All right, so let me move on. Now let's treat upper tail test. You get it? So I'll be editing this one. Upper tail test. So with this one, we are saying that if z computed is actually greater than or equal to z is z critical value. We reject the HO, at null hypothesis, and if z computed is less than z critical value, we fail to reject HO. Okay, so this one is the opposite of our lower tilted. And mind you, the shaded region for upper tilted will be at the right side of the distribution curve, and the lower tilted will be at the left side of the lower tilted. You get it? So let's move on. I hope we are okay with the rules. So the rule is just simple. So for upper test, if the z computed is greater than or equal to z critical, reject HO. If z computed is less than critical value, fail to reject. So it's the opposite of what? Lower tail test. But the lower tail test, it is said if z computed is less than or equal to z critical, then reject. If z is computed is what? Greater than z critical, then we fail to reject. So it's the opposite to this one, right? So let's move on to the two-tailed test. Let's move on to the two-tailed test. So with the two-tailed test, I said after formulating your hypothesis, you see that your mu is equal to a certain number. That one, you divide your alpha by 2. You get it? And one may ask what to be the decision rule. Now the decision rule will be you reject HO or reject null hypothesis if z computed is greater than or equal to the z critical. Then now the z critical here will differ from that of the z critical of the lower and upper tilted, because the lower and upper tilted, the alpha, we didn't divide it by 2. But with the two tilted, the alpha, we are going to divide it by 2. You get it? So this one, you reject HO if z computed is greater than or equal to z alpha divided by 2, or if z computed is less than or equal to negative z alpha divided by 2, we reject at HO. So it's quite simple, right? So let's take note of the rules. Okay, so this one, let me repeat myself. So I said reject HO if the z computed is like this side is talking about the positive. This side is talking about the positive side. So if the z computed, the positive z computed is actually greater than or equal to the positive z alpha over 2, then reject HO. This side too is talking about the negative aspect. If the z computed is negative, it's actually less than or equal to negative z critical. And you want to reject. Otherwise, you fail to reject. You get it. So let's move on. And let's move on to the critical value output. Now, as I said, convert sample statistic, that's the S bar, to a test statistic. So we are converting sample statistic to Z or T statistic. So here we have been introduced to a new table. That's what I call T table. So at first, all what we knew from normal and standard normal distribution, it was what Z table, but now we've been introduced to another table called the T table. All right. So hypothesis test for what mean. So we have two types. So we can test for the mean, like hypothesis test for mean. Right? You have two types of them. So one is if the standard deviation, this one is sigma, standard deviation is known, and the other one is what? If the sigma, standard deviation is unknown. And under the unknown, we also have two types. It can be unknown and the samples will be large or the samples will be small. So hypothesis test for mean, either the standard deviation is known or the standard deviation is what? Unknown. And under the unknown, you may have large samples or small samples. Now let's look at the formula to use when you are calculating the test or when you are testing for that hypothesis. Because you are like how to be your formula to use. The formula to use if you have Z statistic or T statistic. And how are you going to know that with this particular question, I'm going to use Z statistic or the Z formula? Or how are you going to know that with this particular question, I'm going to use what? T statistic or T table? Now, this is the formula. So if the standard deviation is known, if sigma is known, we use this formula. Z is equal to sample mean all over population mean over our standard error. And the standard error is given as standard deviation or the sigma over our square root of n. So that's what we used when your standard deviation is known in the question given. Now let's look at when your standard deviation is unknown, but your sample is what? Large. So when your standard deviation is unknown and your sample size is large, first of all, we can use the T test statistic or we can use what? Z test statistic. So the T2 is given as Tn minus 1 is equal to sample mean minus population mean all over x minus 1 square root of n. Or you can use the x1, the z1, you get it. And let's look at when your sigma is unknown and also your sample is what? Small. You get it. So that one is strictly T statistic. You get what you are trying to say. So let me switch on to the white screen to explain something here. So I think that first of all, consider the n. So if your n is greater than or equal to 30, then we say you are going to use what? Z statistic. And also, if your standard deviation is known, this one we are going to use what? Z statistic. And let's talk about T. So your T, you use T statistic or your T test if your n is less than 30 and also your standard deviation is what? Unknown. Now let's look at the instance where you can use both tests. So Z or T statistic. So that one, if your n is greater than or equal to 30, but your standard deviation is what? Unknown. So this is the preamble. So before you be able to use the statistic, make sure these conditions are satisfied. You get it? So your n, this is small n, small n, small n. So your n is greater than or equal to 30, and your standard deviation is known. That one you use only z table or the z test. And if your n is less than 30, and your standard deviation 2 is unknown, that one you're going to use the t test. Sorry, if your n is less than 30 and standard deviation is unknown, you're going to use what? T test. But you may have a question whereby you can use what? Both z or t test, and that one will be when your n is greater than or equal to 30 by your sigma. Standard deviation is what? Unknown, right? So let's move back to the screen and continue. So I hope we now know the differences. So let's move on. Calculating the test statistic. So let's look at the steps involved to calculate the test statistic. So you have first specify the population value of interest. Formulate the appropriate null and alternate hypothesis. I know by now we all know how to formulate our null and what alternate hypothesis. There's point 2. I hope by now we all know how to do this. But it's very, very important because this second stage will help us to know whether that test is lower tail, upper, or two tail test after formulating our hypothesis. So that second stage is very, very, very crucial. You get it? Now, the third point is saying that specify the desired level of significance. So the third one, most of the time, they give it to us in the question. So at times they will tell you, assume alpha is 0.05, or assume that level of significance is 5%. Determine the rejection region, the 4 points. So you determine your rejection region after you formulate your hypothesis. So if you formulate your hypothesis and your test is lower tail, your rejection region is going to be at the left of the curve. And after formulating the hypothesis, if your test is what? Upper tail, your rejection level is going to be at the right side of the curve. 5. Obtain sample evidence and compute the test. So among the population, you pick a sample, you get it as an evidence, and you compute the test. 6. Reach a decision and interpret the results. So this is where our decision rule comes in. So we have a decision rule for upper tail, we have a decision rule for lower tail, you get it, and we have a decision rule for two tail test, you get it. So let's pick an example. So you get it. Share the white screen. From the they are saying that they claim that we are to test, they claim that the true mean number of TV sets in Journey home is at least 3. Assume sigma to be 0.8, and that the sample of 100 is taken, and the sample mean is 2.84. At least 3. We learned this one is linear programming. At least 3 means greater than or equal to. At most is less than or equal to, right? So first of all, we know the standard deviation, that is the SD. Standard deviation to be what? SD to be 0.8. We know sample mean, that's the S bar to be what? 2.84. The S bar or add the bar. Then we know that Okay. Let's move on to formulate our hypothesis. So we move to HO, then what? HA. Now, remember I told you that the HA, yes, then the sample size, that's the N. So your N is what? 100. The N is what? 100. Good. So your HO represent the null hypothesis. And previous slide, I read that the null hypothesis always contains the equality sign. So is that equal to or greater than or equal to, or and what less than or what equal to? So equal to, less than or equal to, greater than or equal to. These are the three signs under our null hypothesis. And with the alternative hypothesis, it never contains equality sign. So they are not equal to, only greater than, only less than. It never contains the equality sign. So this one is talking about at least 3. If it's at least 3, then it will be what? It will be the mean for
greater than 3.
So it will be the mu for what? The mu HO, the mu will be at least 3. So greater than or equal to 3. So greater than or equal to 3, right? Then the HA will be, you always know that the mu, it will always challenge the mu. It will always challenge the mu. So if this one is greater than or equal to 3, then this one will be what? Less than. All right. So this, you formulated your hypothesis. So this is your second stage, and it's very, very crucial. And looking at this, I said you have to determine your rejection level, and you are going to determine your rejection level based on what? Like hypothesis. So this one is lower tail test. Because I said for lower tail test, your HO, the mu is greater than or equals to 3. And for the upper tail, the mu is what? Less than or equal to 3. So this one will be lower tail test. So this one is going to be like this. So the rejection level or rejection region will be here. To the left, you get it. All right, so let's move on. Now let's move on to solve the Z critical and Z what computed. Now in the slide, it told us that suppose that alpha is 0.05 is chosen for this test. So let me copy that and post it there. So that sign is alpha. I don't know why it's showing that sign. So this one is alpha. I don't know why it's so the alpha is what? Alpha is 0.05. That means 5%. Level of significance is 5%. Okay, so we have all this information. Now we move on to the next step. Now the question you have to ask yourself is, which type of test am I going to use in this particular question? So I've given you the rules. So for Z statistic, your N must be greater than or equal to 30, and the standard deviation must be what? Known. You get it? And looking at this question, our N here is actually greater than or equal to 30. our standard deviation is what? Known. So here we are going to use what? Z test or Z statistic. And we know that for Z statistic, the formula is what? S bar minus population mean all over the standard error. And we know standard error is the standard deviation all over square root of n. We have this information, we just substitute. I'm using mouse, and so that's why I'm writing like that. So your sample mean, okay, so your sample mean is 2.84. Your population mean is what? This one, 3. All over standard error. So standard deviation, that is 0.8. But square root of what? 100. That's the square root of 10. So this you get our Z computed. So just point it for me. Give me the answer.
-2.
Okay. So this one will be Z computed, right? So we are saying the Z computed is what? -2. Now we are saying that we should test the claim. How are you going to test the claim? We just use your decision rule. Now the decision rule is that compare your Z computed with your Z critical value. Now we know that the Z critical value must search it using what? The Z alpha. Now the Z alpha is what? 0.05. That's the level of significance. It's talking about the probability. So the percentage is what? The probability. So you have to go through the graph and look for 0.05 and trace the value that gave us the probability 0.05. So let me share the table. So we are going to look for what? 0.05. So where is 0.05? 0.05 is here. You can use this one or you can use for this one, because this one is approximately 0.05. Because when you come when you change this one to 2 decimal places, you get a 0.05. So let's use this one. So you trace it up like this. Then you also trace it to the left side like this. And that will give you your what? Z critical value. So what are you getting? Is plus or minus 1.64. Why am I writing plus or minus is 1.64? Now it will be plus when your Z computed is what? Plus. It will be minus when your Z computed is what? Minus. And because this one is talking about lower, like the lower tail test, the Z computed will be negative and the Z critical must be negative. So it's negative 1.64. That's what we got for the Z critical. Now we should compare between the two. So Z computed and what? Z critical, right? So Z critical is minus 1.64. Z computed is minus 2. So the critical value is here, minus 1.64. Minus 2 will be here. So if the Z computed is in the rejection region, just reject the HO. Better still, if Z computed is less than Z critical, the rule is saying that reject HO. So if Z computed is actually less than or equal to Z critical value, reject what? HO. What will be your conclusion? So your conclusion will be that the average number of TV sets in Ghanaian homes is less than 3, not at least 3. So it's not 3 or more. We are saying that we should reject this claim that in the typical Ghanaian home, the number of TV sets, the mean number of TV sets is what? At least 3. And at least 3 is what? 3 or more, 3 or greater. And by using this hypothesis testing, going through the Z test, comparing the Z computed and the Z critical, using the decision rule, they are saying that we should reject the claim that the average Ghanaian homes, the number of TV sets is what, greater than 3. So your conclusion is that in average, like in typical Ghanaian home, the average number of TV sets is what? Less than 3. That will be your conclusion. You get it. So we should reject the null hypothesis. We should reject the HO that in every typical Ghanaian homes, the number of TV sets is what? At least 3. We should reject this claim. Right. So this one is for lower tail test. Lower tail test. So this one is, we've used this critical value approach. We can also use the p-value approach. And the p-value approach, you compare the probabilities. So you have to, if you are using p approach, you have to search for the probability of what? -2 using the distribution table. You compare it with what? The 0.05 here. Now the decision rule is opposite to this one. That's why I don't want to confuse other people with it. So we use the critical value approach, simple. But if the question demands you compare the probabilities for the p-value approach, you compare the probabilities. You compare the alpha value with what? The p-value. So the p-value will be the probability of what? The Z computed. I repeat, p-value is the probability of what? The Z computed. And we also know Z alpha to 0.05. They will compare. And I'm saying the decision rule is opposite to this one. So if you want to use that one, you can do your research on it, learn more about that one, and use that one. But for me, I would like to use this one. Because if I teach the other one, it might confuse you. That's why I want Sorry, that's why I want to use this one. You get it. So let's move on to the apathy test. I hope this one is okay, right?
Yes.
So let's move on. Okay, so as I was saying, this is one tail test with alpha 0.05. So since standard deviation is known, so I've explained this one. So we get HO, we get null hypothesis if Z computed is less than or equal to what? Negative Z alpha, that's the Z critical value. Because this is lower tail test, so it will give you negative values. Otherwise, we get. So that's the same rule I give it to you. So we've explained this one. So this is the workings. And I'm using it. We reject the null hypothesis that the mean number of TVs in the Ghanaian is what? At least 3. So the conclusion will be that the mean number of TV sets in Ghanaian homes is less than 3. Because we are going to reject the null or the H naught. You get it. Let's move on. Then this is the P. This is the P approach that I was explaining. So convert sample statistics. That's the S bar to test statistic. So we are converting to Z or T test. Obtain p-value from a table or a computer that matches with that test statistic. So after computing for your Z value or T value, you then find the probability of it using what? The table. So you are going to use, if it is T, you find the probability of that value using the T table. If it is Z, you find the probability of that value using the Z table. Then you compare the p-value with alpha. Now, if p-value is less than alpha, reject HO. If p-value is greater than or equal to alpha, do not reject. So p-value is probability of obtaining a test statistic more extreme equal to less than or equal to or greater than or equal to than the observed sample value given. HO is true, also called observed level of significance, smallest value of alpha for which HO can not be rejected. So this will teach you the p-value approach. This should give you the p-value approach. So as I said, I don't want to confuse you with the p-value approach. So compare the p-value, just like take note of the rules. So when you are being told to use the p-value, you will use the rule to find your decision. So if p-value is less than alpha, reject HO. If p-value is greater than or equal to alpha, do not reject HO. Do you get it? Okay. So here, you are saying that P is 0.228. So where did you get the 0.228? The 0.228 was the probability of what? The -2. That helped us get the 0.228. Then our alpha probability for critical is 0.05. That is significant. So we compare the two. Since p-value is less than what? Alpha, we reject the null hypothesis. Other than that, we will fail to reject. Right? So the p-value approach is quite simple. I can be what confusing. All right. So just stick to the rule. This rule. If p is less than alpha, reject HO. If p-value is greater than or equal to what? Alpha value, do not reject. All right. So any question before I move on to the upper tail test? Any question before I move on to upper tail test? Any question?
Come again. Network issues. Come again. I said.
I was saying any questions. Do you have any question before I move on to upper tail test?
No, please. No, please.
Okay. So the rest, are you okay? So silent means consent. Let's move on. Okay, so let's move on to the upper tail test. Upper tail test when what? Sigma is known. This sign is sigma. It means the standard deviation. This sign. Standard deviation. You get it. All right. So a phone industry manager thinks that. So let me copy this one. All right, so as I said, this one is alpha. I don't know why it's showing like this. So this one is alpha. So this one, we should assume that alpha is what? 0.1, not 0.05. So we have to go and set the critical value again. Now, so this one, let's solve this one. We know, let's now formulate our hypothesis. We are saying a phone industry manager thinks that the customer thinks that customer monthly cell phone bill have increased and now average over what? 52 Ghanaian cedis per month. The company wishes to test this claim. Assume what is that? Come on. So assume sigma is 10. Assume sigma is 10, standard deviation. sigma is what? Is known, and that the sample size of 64 is taken. And the sample of 64 is taken. And the sample mean is what? 53.1. So now let's jot everything down. So alpha is what? Alpha is equal to 10. Sample mean, that's the S bar, is equal to what? Sample mean 53.1. Not again. The sample size, that's the N, is what? 64. Alpha value. Alpha value is 0.10. Okay, so we have this thing. Let's now formulate our hypothesis. So now HO, we are saying that the mu and the HA, the mu. Now, most of the time, the null hypothesis is given, like you see that one in the first statement. You get it? So you see that one first before you see what the alternate hypothesis. And sometimes the alternate hypothesis comes before the null hypothesis. So looking at this question, they are saying a phone industry manager thinks that the customer monthly cell phone bill have increased. So things have increased. Have increased is solely greater than have increased. Have increased by this, so greater than. And now greater than, only greater than false and alternate hypothesis. But we are saying that the alternate hypothesis never contains the equality sign. So it's either not equal to, less than, greater than. That's under the first ones. So with this particular application or particular question, they introduced or they brought the alternate hypothesis before you yourself you write the null hypothesis. But most of the time they will give you what the null hypothesis or H naught, then you will write the alternate. But with this particular question, they gave us the alternate hypothesis, and after that you write your null hypothesis. Or alternate hypothesis was greater than what? 52. So the mu will be the opposite, less than or what? Equal to 52. So that is your formulation. Now with this, I told you determine whether this one is lower tail test or this one is what? Upper tail test. Now this one, the HO, the mu was what? Actually less than or equal to 52. If the mu is the H naught, the mu is less than or equal to a certain number, then it's talking about what? Upper. Talking about what? Upper tail test. Okay. Okay, so upper will be here. So the rejection region is here. So you now ask yourself, which test are you going to use? Are you going to use T test or what? Z test, right? And I told you or I showed you the rules here. So first of all, for Z statistic or Z test, make sure the N or the sample size is greater than or equal to 30. Standard deviation is known. And with this particular application, the N is what? Greater than 30. Standard deviation is known. So you use what? Z test. So Z is giving us sample mean minus what? Population mean all over standard error. Standard error is given as what? Standard deviation all over what? Square root of sample size, square root of n. You know all these things, just as it is. So sample mean is what? 53. 53.1 minus population mean, that is 52. All over what? Standard error. The standard error is standard deviation. Standard deviation is what? 10. All over square root of population size. Population size is 64. So this one will give us the Z computed, right? So we get point and give me the final answer.
Uh, 0.88.
Now we now know our Z computed. Now let's move on to find our Z critical, right? So Z critical will be, I've taught you how to do that. So we know our alpha value, so it's 0.1. We have to move on to a graph. You come through, you search for 0.1 as the probability. You trace to get your Z critical value. Now let's do that. So 0.1. Let me share the table. All right, it's here. So let's look for 0.1. So where can I see 0.1? Where can I see 0.1? All right, so 0.1, where is it? So 0.1 to be here. Okay, so 0.1 is 0.11, so it's this one. So you've seen the probability here. Now let's trace it. So this is the probability, right? Now we are going to look for the value that helped us got this. That helped us got this probability. So you trace it to the top and also to the left. So it's plus or minus 1.2, then 0.08, so it will be 1.2, 0.08. When you add it, you get 1.28. We're going to search for the value that assists or brought us this probability. You get it? All right. So this is how we search for the critical value. To get it, you are going to use your alpha value. You search for that alpha value. That's your probability or the significance level. Then you trace it to the top and to the left. You add the figures, you get your critical value. So we are now having plus or minus 1.28. Let me see to this one. Because it's positive, let's write 1.28. I already know what we are going to compare. So we compare Z computed and what? Z critical. And you know that Z computed is what? 0.88. And Z critical is what? 1.28. So the critical value is what? 1.28. Now 0.88 will be here. Now, does not fall within the rejection region, right? Does not fall within rejection region. So the Z computed is actually less than what? Z critical. And for the upper tail test, upper tail test, if Z computed is less than Z critical, we fail to reject. Other method is you use this 0.88 and 1.28. Now 1.28 is a critical value. You get it, and the rejection level or rejection region is here, moving to the right. Now the 0.88, which is a Z computed, does not fall within the rejection region. So you can use this curve to arrive at your decision. Okay, so this one, the 0.88 is not within or inside the rejection region. So we will conclude by using this curve that we fail to reject the H naught. You get it? So we fail to reject the H naught. Or you can use this one, the normal rule that we know Z computed is less than at Z critical. When this happens, we reject. So if we know the rule already, if Z computed is less than Z critical, we reject. Right. So this one you can use P-value approach. So P-value approach, you go and set the probability of Z computed 0.88. You use the Z table to search the probability for 0.88. You compare it with what the 0.1, that's the alpha value. Then that one to use the rule and what. But what I'm trying to say here is that the P-value might miss with you. Do you get it? So maybe you be confused because the rules are not the same. P-value and critical value. Even if it's P-value or critical value for lower tail test only, the rule differs. Do you get it? So I won't advise you to use that. But if the question demands you or requires you to answer that way, beg, use that method. So that one I've already taught you the decision rule. So you compare the p-value and the what alpha value. If p-value is less than or equal to the alpha value, you know what to do. If p-value is greater than the alpha value, you know what to do, right? So this is talking about the upper tail test. So any question before I move on to the two tail test? Do you have any question? Do you have any question before I move on to upper tail test?
No.
All right, so let's move on. With the p-value, as I said, we have two methods, right? Critical value approach, the approach is critical value approach and the p-value approach. And we are saying that we fail to reject since Z0 is 0.88. It's actually less than or equal to what? 1.28. So there's no sufficient evidence that the mean deal is over 52 guarantees. So we fail to reject. You get it? The p-value is here. You can learn the p-value later. You get to calculate the p-value and compare to what alpha, because the alpha is already given to you in the question. That's the significance level. Then the p-level, p-value is the probability of what the z or t computed. You get it? Yeah. So do not reject HO since p-value is this 0.1894 greater than alpha, which is 0.10. So as I said, the p-value and the critical value, it differs. Even if you are using it for one tail, let's say, if you are using both approaches for lower tail or both approaches for upper tail, the decision rules are different. That's why I'm teaching only one approach, as the critical value approach. I will urge you to learn the p-value approach yourself. So the p-value is not anything difficult. You just compare the p-value and the alpha value. The alpha value is already given in the question. The p-value is the probability of the what? P or N, Z or T computed. You get it? So now let's move on to the two-tailed test. Now the two-tailed test here, let's read this question. So the average cost of the hotel room in New York is said to be $168 per night. A random sample of 25 hotels resulted in this is sample bar 1725 and x is equal to 15.40. Test at the level 0.05 level. That's the significance level. Right. Let me share the right. So this one, let's move on. So we know the population mean to be 168, but that is the average cost of hotel room is what? That's talking about the population, the New York. The mean is here. We have S bar, we have X, we have sample size, we have what? Alpha. So here the mean was equal to what? 160. That's the population mean. Let's look at the sample mean. Sample mean was 172.5. X is equal to 15.40. N is equal to what? 25. Alpha is 0.05. Now remember, okay, I'll come back. So this one, which type of test are you going to use? Are you going to use Z test or T test? Now we refer to the rules here. So we are saying we will use only T test when the sample mean is what? The sample size is less than 30 and the standard deviation is what? Unknown. You get it? Now when you look at the question here, you can see that the sample size, which is N, is less than what? 30. We don't have what? Standard deviation here. So standard deviation is unknown. So N is 30, standard deviation is unknown. So we then use what? The T test. The formula for the T test, you saw it in the slide. So the T test is T subscript N minus 1 is equal to sample mean minus population mean all over X. This one is not standard deviation, X. So they give X to us over square root of what? N. It just says in the value. So sample mean is 172.5 minus population mean, that's the 168. Then population mean is what? Sample size is 25. So our T computed becomes
1.46.
Alright, so 1.46. I forgot to formulate the hypothesis, so I can come back to solve. Okay. So this one is x is what 15.40. How we can see it? Let me paint it. Make it. So 15.40 divided by 12 and it's 25. So you get one. This one is what T computed. We are not using Z computed because we used what? We used T test. So the name will be T computed, not Z computed. So this time we will be using the T table, not the Z. Now let's look at the T critical. Now I forgot something. Let's come back to it. Let's formulate the hypothesis. So HA. So for HO, the mu is, they are saying the average cost of hotel room in New York X2B is said to be what? Once it's said to be linear program is said to be exactly the sign is what equal to 68. So the HA challenges the status quo. So this one, the HA or alternative what not equal to, you get it. So this is our formulation. Now, seeing the equal to sign tells you something that, it tells you something. It will be two-tailed test. So let me draw it here. This guy. It will be here. Yeah, so the rejection regions are two. And let's then solve the T critical. T critical. How do you solve the T critical? We said the alpha value is what? 0.05. So normal circumstances, you have to search for the 0.05 in the Z table, and we compare it with what the T computed. But note, because it's two-tailed tests, we are going to divide alpha value by 2. So here alpha value won't be 0.05. You divide that one by 2 because the question is talking about two-tailed test. So our answer will be what? 0.025. That's 0.025. You get it. So this will be our alpha value. This will be our alpha value. Now I may ask, how are you going to find your T critical? And you're going to use the T test, T table, right? So let me share the table here. Before I share the screen, we said that the T is what? N minus 1. So if N minus 1, what is the N? N is 24, right? So T N minus 1 will be what? T N is what? 25, right? 25 minus 1. That will give us what? T24. So you are going to search for T24, and the alpha value is what? 0.025. Right, so we are going to use this to search for our critical value. Now the critical value, let's move on to the screen. So you find that on a T So this one, they say entries in the table gives t value for an area of probability in the upper tail of the t distribution. For example, with 10 degrees of freedom and 0.05 area in the upper tail. You get it? So here we said our t is what? 24. So 24, this one. And our alpha is 0.005 because we've divided alpha by 2. 0.025, then 24 to what? Plus or minus 2.064. Plus or minus 2.064. So it's plus or minus 2.064. So this is a critical value. 2.064 negative for this side. This one is positive 2.064. Okay, then we compute our represent the t computed on the graph. So negative 1.64 will be here. Negative 1.46. And a positive 2 will not be in the shaded region. Positive 1.46. So you can use the curve to, arrive at a decision. You get it? So looking at this one, let's take the positive aspect. The z computed and what is z critical. A t computed, what a t critical. Let's take the positive before we take the negative. So positive is 1.46. Negative is what? 2.064. So t computed is what? Less than or equal to less than 2.064. So we do what? We fail to reject. We fail to reject. So the decision will fail to reject. Better still, you can use the graph here because positive 1.64 is not in the region here, the shaded region, but the shaded region starts from like 2.064. So the 1.46, which is t computed, is not within or is outside the rejection region. Therefore, we fail to reject. The same thing applies to the negative side. The negative 1.64 is not in the rejection level for 2.064. It means we do not, we fail to reject the null hypothesis. Right. So we have, this is our two-tail test, done upper tail and lower tail. Now I want to make some corrections in the upper tail test. You get it? I want to make some corrections in the upper tail test. So I said I'll come back to the upper tail test and teach you something. So when you're using p-value, so if you are using the p-value approach, okay, we are much interested in what? The shaded part, you get it? So that's moving to the right. And we are using z table. And remember this in normal and standard distribution. Normal and standard normal distribution, you get it? That one, the z table reads to the left. Now we want the p-value for what? The z computed. And the p-value will be upper tail, that one will be to the what? Right. And the z table to reads to the what? Left. So after solving for the big part here, that one is reading to the left. Whatever you get, you subtract it from what? 1. That one will give you the probability or p-value for the z computed. So they did it here. So this one, it was greater than what? Greater than or equal to 0.88. And I'm reminding you that in standard distribution, so if this one z is greater than or equal to 0.88, you get it. We learned something that with the z distribution table, it reads to the left, so it only needs less than or equal to sign. So when you see something like this, it will be 1 minus the probability of z. Then you change the sign to what? Less than or equal to z less than or equal to 0.088. That was what I was trying to explain. I'll give you the region to this part. You get it. So this is about Pvalue. This brings us to the end of this session. Thank you once again. The next video I'll be releasing correlation regression. Okay, so don't forget to like, subscribe, and share our YouTube channel. Thank you. Have a wonderful day. Bye bye.